Before talking about Kafka, let me ask you a simple question. How would you save millions of user interactions on your website without slowing down the user experience? You might be thinking that it would slow down the website or overload the database. Don't you worry, that's exactly what Kafka is here for. Let's take an example of what problems we had before Kafka was developed and how Kafka solves it. Assume you are building a food delivery app which is composed of different services such as the order service and the payment service. The order service is directly connecting and sending data to the payment service. Since there are only two services, it is very easy to share the data between them. Now let's say you add another service, the analytics service, which shows a graphical representation of your orders and payments data. This service connects both the order and the payment services to display data in the form of graphs. As you can see, increasing the number of services also increases the complexity between them, which becomes very difficult to manage. To handle this problem of tight coupling, you can loosely couple your application by introducing a middle application called Publish Subscribe application, or in simple words, PubSub application. In this setup, publishers publish the data to this middle application and subscribers subscribe from it to receive the data. Now, what if you introduce another service like a notification service which consumes different kind of data such as notification data? You would have to add another PubSub application between notification service and other services like the order service. It means that in real life, we could have many PubSub applications running. Rather than managing multiple PubSub applications, what if you would have a single centralized system that allows for publishing generic types of data, which will scale as your business grows? You got it. That's what Kafka is all about. Kafka, developed by LinkedIn, is an open source system for building real-time data pipelines and streaming applications. The applications that generate the data are called producers. The applications that consume data are called consumers. The smallest unit of data in Kafka is called a message, which is produced by producers, stored in Kafka, and consumed by consumers. Kafka stores those messages in a structure called topic. Inside a topic, there can be one or more partitions. For example, let's suppose you create an orders topic with two partitions. Inside those partitions, each message is stored in increasing offset starting from 0. Every new message will have new incremented offset inside the partition. Now let's see the Kafka message structure. A message contains metadata like topic name, partition information, and a key and a value. All messages with the same key go to the same partition. Let's assume a message with the key user1 is produced by a producer and stored in the partition 0. If another message is produced with the same key, it gets stored in the same partition. If key is different, it could go to a different partition. Topics are made accessible by servers called brokers. Producers and consumers actually connect with brokers to write and read data. A topic can be spread over many brokers. Brokers share the load by storing different partitions. One of the core benefits of Kafka is its replication functionality, which allows partitions to be replicated across multiple brokers, improving scalability and fault tolerance. The broker containing the leader partition is called leader broker for that partition. All producers must connect to the leader of a partition to write messages, but consumers can fetch from either the leader or from one of its followers. The controller is a special broker in Kafka cluster. Its job is to manage the cluster and assign partitions to the brokers. Consumers work as a part of consumer group, which is one or more consumers working together to read data from a topic. This enables parallel processing and fault tolerance. Each partition is assigned to a single consumer within a consumer group. When a consumer reads a message, it commits an offset to the partition, so the next message it reads will be the one after the last one it processed. If you like this video, don't forget to subscribe. Until the next video, bye bye.